Thank you for joining. So here the goal is to give you a deep dive into our nxAccess solution and how you can move your trading logic from software to FPGA in 4 steps. So first, you might know us from our other products. So our full hardware feed under, which we talked about yesterday, NX Feed, our network bandwidth management solution, which we call NX Link, and another product that I'll touch on today, which is our FPGA development framework, NX Framework. But as the title mentioned, today I'm going to go into a deep dive of nxAccess, which is our end-to-end trading engine solution. So first, in talking about nxAccess, we find it really interesting to show kind of the journey that we see our customer taking from higher feature, higher latency application all the way down to the fastest and more reduced functionality solutions. So they often start from a software solution that is using either a software vendor or in-house code, and they can start by integrating our FPGA feed handler, NX Feed, and basically accelerate the whole processing of the market data using FPGAs. When that's done, the next step is, of course, to accelerate the execution part of things, as well as having some logic running inside the FPGA itself. That's where nxAccess sits. It's really going to provide you the best of both worlds between functionality and latency. But we also understand that some customers, when they trade at the sub 500 nanosecond latency of nxAccess, they tend to find out that there are certain strategies that need more effort into the latency, and so we can take them on to our FPGA development framework, where they will be able to reuse key IPs that we used in nxAccess, so it will be known technology, and customize their trade to really achieve the performance that they need for those very latency sensitive trades. One of the things that's really interesting to look at in those various approaches is what NX does and what our customer do, as well as how much of that work is going to be hardware work and how much of that work is going to be software. So of course, the software application is going to be fully on the customer and it's going to be fully software. On NX Feed, NX is going to take care of the whole hardware development and provide an off-the-shelf firmware, and our customers will only have to interface with our software C++ API. On nxAccess, as mentioned earlier, the goal is to be able to have some trading logic within the FPGA. And so on that product, then our customers will have to do software to integrate with our APIs, but as well hardware development to be able to develop their strategy that will run within the FPGA. Of course, for customers that need to go to the lower latency route and higher customization, then our FPGA development framework is going to provide key IPs, but then there's going to be more hardware and software development on the customer side. So talking about nxAccess, I'm mostly going to focus on the execution capabilities of that solution, as we talked about the market data yesterday. So looking at a high-level diagram of the nxAccess solution, we can see that there's 3 main components, both on the FPGA and on the software. First, we start with a full FPGA feed handler that is going to come with its associated C++ library for configuration, monitoring, but also data transmission. There is an execution stack, which is going to be also FPGA accelerated, and which will come with a C++ API for configuration and interaction with it. And of course, in the middle, there is space carved out into the FPGA for customer logic to be deployed right within the FPGA. And the thing that we can see on this diagram, which is really interesting with nxAccess, is that all of our customers using this solution have kind of a dual pass trading logic. They have a very optimized and low latency trading path that goes through the FPGA, and as I mentioned, and I will show you, is able to react under 500 nanosecond. But they can also have a more complex and more feature complete trading path that goes through the software, and that software application is going to be able to receive exactly the same market data update than the hardware strategy, and will be able to constantly communicate with the trading logic within the FPGA. So in order to explain how our execution stack works, because we think we're doing something slightly different than everybody else, we put together those animations that really explain how our execution stack is software driven, but the performance is the performance of the FPGA. So you can see on the left, you have the feed handler, in the middle, the trading logic, and on the right, the execution stack. And at the bottom of your screen, you have your software application using our execution API, which is that little purple bar. So the first thing that you will do running your application is using the API to preload orders or a template of orders directly within the FPGA. So the idea is to make sure that you can have a lot of them, up to 16,000. And in this example, we're just going to preload 3. And you can see that, for example, in the buffer 1, this is a template of order. That means that it's a buy order, but the symbol, price, and quantity are left out. They are left out for the FPGA trading logic to be able to provide at the moment of trigger. But you can also create full-blown orders. For example, here the mass cancel in buffer 3 is ready to go. The FPGA logic will not have to provide any additional data for this order to be complete and sent to the exchange. Once you've configured those buffers, you can use our C++ API to start the feed handler. The feed handler is going to decode and normalize the data, perform A/B arbitration, build the book, and then, as we saw before, provide market data updates both to the hardware trading logic and the software one. Your hardware trading logic then is going to be able to crunch the data, and an opportunity might arise. And if that happens, the hardware trading logic might be interested to trigger a buy order, so template 1, and provide the missing field, IBM $120.75 quantity. When that happens, the execution stack's job then is going to update the order with those fields and make it complete. And when that's done, it will send it to the exchange. So to summarize, every trade with nxAccess is going to happen in 4 main steps. The first one is going to be to upload orders or template of orders within the FPGA. Again, up to 16,000 orders or template of orders. Then it's going to see a trigger. That trigger can come from the hardware logic or from the software logic. Then the execution stack is going to be in charge of updating that order and sending it to the exchange. Doing that really allows us to have a very simple interface for the hardware trading logic, which really reduce complexity and help our customers be really efficient in the development of their logic. That means that the hardware trading logic itself is completely unaware of the actual market data protocol and the execution protocol, and just have to pick a buffer and provide required field in the right format for orders to be sent. So we put together a last little animation which really explains how a software application is able to completely take over the communication with the exchange on the TCP sessions. So you can see here, it's just a zoom in of the execution stack. We can still see the hardware business logic and still see the software application. So the first thing that you have to do is, of course, open a session. And so that session is going to be opened through the FPGA, which include TCP stacks. And you're going to have be able to have the communication with the login and logout message heartbeat managed directly from the software, as this is not latency sensitive. When that happens, that means that you're able to determine what is going to be the sequence number of a given session, and then configure the execution stack to know what to use. You can see here that, like before, we've preloaded 3 orders into the execution stack, but you can see that it's slightly more detailed. In addition to quantity, price, symbol, we also added 2 things, the order ID and the sequence number. And those fields will really focus on. The previous one will be, like before, provided by the hardware business logic. The order ID and the sequence number will be fully managed by the execution stack. So like before, at some point, your hardware business logic might take the decision to trigger an order. For this, it's going to specify buffer 1 and provide the required field. So here there's also the side and symbol, price, and quantity like we saw before. But before sending it, you really have to make sure that the order is compliant with the exchange protocol. And that means that you need to provide a TCP header, a sequence number, as well as an order ID. Those 2 fields are fully managed by the execution stack, which means that you can have traffic coming from the hardware business logic or the software business logic, and you have no race condition. The execution stack will always be able to send any order at any time without having any message not being compliant with the exchange protocol. All right, so that's how our execution stack does. I think that now what I want to present is what we do and what our customer have to do, what you have to do to be able to integrate with nxAccess. So let's do top to bottom. So on the execution stack, we saw that the solution provides hardware TCP stacks. It's able to allow you to preload up to 16,000 orders or template of orders. Sorry. Your software can preload, trigger, send, or direct send directly through the FPGA. And then you have a whole management of the sequence number, timestamp, and anything that's going to be needed to be compliant with an execution protocol. The one thing that I didn't mention is that every nxAccess solution includes an audit trail pass, which will send you a copy of everything that is sent and received on the TCP session that you have open with the exchange. That way you can troubleshoot easily when anything happens or build the audit trail for your risk and your back office. On the execution side, you have to do some developments. You have to integrate with our execution API. And that integration will allow you to integrate any support for an execution protocol that you have, so you're able to send those orders directly through the FPGA. On the feed handler side, the only requirement is to integrate against our C++ API to be able to configure the feed handler, the list of symbols that you want, what depth of book, what type of message that you may need, but also make sure that your application is able to consume market data updates. And then finally, on the trading logic, of course, you have to develop that hardware trading logic, but on the software side, you will have to develop the interaction with that trading logic. So very often our customers use the high-speed interfaces that we provide to have configuration constantly sent to the hardware trading logic, but you will also have to make sure that you can constantly monitor the market data and send orders directly from your software application if needed. So coming back to the point of this presentation, how to move from software to FPGA in 4 steps. So the first thing that we do with our customers is look into what they have, what server they have, where they are hosted, and make sure that we arrange anything that they will need to rack an FPGA card directly into their server and connect it to the exchange. While that happens, usually take 2 to 3 weeks, we can start on step 2, which is making sure that they can work on the integration of our market data API. For this, we include simulation models, which allow customers to start developing and testing without having the FPGA. You can use PCAP file or not normal software cards, network cards, to be able to test and integrate our API. When that's done, you can move on to the integration of our execution API. Here, because it's a tighter integration between the hardware and software, you will need to have the FPGA racked and connected. But again, we provide a lot of examples and documentation to allow customers to write the code that is needed to be able to use that execution stack and test it. And finally, again, this can happen in parallel. The last part is going to develop your hardware algorithm. To do that, you can use either HDL or HLS code, and this can take from 4 to 6 weeks. Again, we provide quite a bit of examples for our customers to have a first start and be able to hit production with a simple algo very quickly. Talking about the development workflow, here it's an HLS development workflow, but that would be similar for HDL. We really want our customers to be as autonomous as possible. So you can have simulation models as well as the capacity to do your development and iteration without us ever being involved. So we will provide you with test benches for the code as well as hardware packages to make sure that you can autonomously generate your own firmwares. All that package will include scripts to make sure that you can simulate and build, but also will make sure that you can change the configuration of the various blocks, the feed handlers, and the execution stack to really meet your needs. So I mentioned the performance earlier. So here I have 2 slides that highlight the performance of nxAccess when using the QED market data protocol as input and the CME iLink 3 as output. Every order that we will send in that test are 300 byte iLink 3 orders, which means that on the wire it is 380 bytes. What we do is that we look into the size of the trade summary message of the QED protocol, and depending on that size, if it's from 0 to 10, we are going to send 1 order on the TCP session 0. If that size is between 10 and 20, we are going to send 2 orders, 1 on session 0, 1 on session 2, all the way up to a maximum of 8 orders. So if the size is between 80 and 90, the solution will send 8 380 bytes packets on the wire. And the first thing that we did is that we configured the solution to use just 1 TCP stack and one 10 gig port, and we looked at the in and out latency for each session. So the first session, the first order ever to come out the door, had a 50 percentile latency of 437 nanosecond. And then after this, we graphed the latency profile for any additional session. And so keep in mind that the maximums here are really due to serialization delay. We have to send 8 times 380 bytes through a 10 gig link. So to prove this and to prove that the bottleneck is the serialization, we run the exact same test, but this time using the 2 TCP stack that is included in nxAccess along with 2 10 gig ports. The first thing that we were happy to see is that running that test, the performance of the first session is exactly the same. So there's no improvement, but at least it's very, very stable. When looking at the performance of the other sessions, we can see that there is an improvement of up to 41%, simply because we have now 20 gigabit per second of bandwidth over 10. All of this is highly detailed on our website, so you can go to enix.com/performance. We really take pride in being as transparent as we can about how we test and the performance that we get. On that website, you will be able to see everything from the minimum and maximum latency, as well as the capture that we use for those tests, and more detail about the hardware that we use for measures. So just to continue on nxAccess, the 2021 roadmap is going to include two things that will likely interest our customers. And since it's a subscription-based solution, our customers just get monthly updates with new features and performance updates. So the first thing is that we are going to upgrade to the version 5.3 of NX frameworks, which I'll present right after, which provides lower latency MAC PCS and TCP UDP stacks. But we're going to include two new features. First, we're going to include a pattern matching functionality to be able to have simpler signal detection from the market data or the execution feeds. So the idea here is to be able to really quickly extract data from those feeds and turn it into a trading signal without having to go through the feed handler, which of course does more processing and normalization for convenience, but that's a trade-off for performance. The second feature that we'll be adding at the end of this year is a pre-computing functionality for faster response time on the execution side of things. That means that the execution stack will constantly recalculate our buffers to make sure that they're ready to go. So if you have a sequence number that needs to be inserted, if an order is sent on that session, the solution will make sure to update one buffer constantly that it bears the next sequence number and it's ready to be sent as soon as possible. With this, looking at calculation, we are going to break the 300 nanosecond latency barrier with the same test condition that I presented just earlier. And of course, for our customers to be able to continue trading on exchange that update their execution or market data protocol without any worry, we will provide several exchange-driven changes support in all regions. So how can we help with nxAccess? So we have three approaches. The first one is do it yourself. We provide you a package with demonstration and documentation that really should help you take off and create your project and go to production on your own if you wish to. We have customers that do that take secrecy very seriously and don't want to tell us what they're doing, and they just take our package and create their application and deploy it in production. The most common approach that our customers take is the jumpstart approach. So the whole idea here is that if you have an application that needs to do 100%, you can work with us on defining what 80% means, leaving out 20% of your secret sauce on the side. Then we can work and develop those 80% and hand over a project with those 80% so you can add the last 20%, which is proprietary logic. And finally, we do have some customers that are using a fully maintained approach where we work with them on the specification of the exact trading logic, we develop it and we maintain them we maintain it for them. And then finally, in terms of technology, on the software side, it's going to be C++. And as I mentioned, on the hardware side, it's going to be HDL in VHDL or Verilog, or HLS if you have software engineers that want to help reduce latency of your trading applications. And so finally, before I leave you, the one last thing that I wanted to present is the upcoming 5.3 release of the NX framework. So for our customers that are looking to go the extra mile in latency optimization, we have an FPGA development framework, which includes everything that you need to really efficiently create your own trading application. So it includes board support package, which abstracts the underlying hardware so you don't have to worry about that, and you can make sure that to move your application from one FPGA platform to the next really efficiently. It includes everything that you need for your workflow in terms of configuration file and scripts. And then, as I mentioned before, it includes our core IP, so our Mac PCS, TCP, and UDP stack, as well as our PCIe DMA stack. And so the version 5.3, which is about to be released to our customers, includes an updated Mac PCS and TCP stack. So our new Mac PCS is going to show a minimum latency of 27.23 nanosecond. That's a round trip, including the PMA, and that's a soft-to-soft measure when running at 322 megahertz. And our TCP stack is now going to provide a latency, soft-to-soft round-trip latency of 51.42 nanoseconds for 1 byte when running at 350 megahertz. In the case of nxAccess, which is going to soon move to that version, that means that the latency of the TCP stack when sending an order is just going to be 5.7 nanoseconds. As mentioned before, all those numbers are available on our website. You can go to nx.com/performance to get all the details about how we got those numbers, what they mean, and make sure that we're not just using numbers as a marketing ploy. That's all the time that I had for you today. If you have any question, Kieran and I will be at the booth for the rest of the day, or you can go to our website and just go to the Contact Us section. Thank you very much.